The objectives for today. Amanda, read the first objective for us.
Students will understand that a function is a rule that assigns each input exactly one output.
So that's our first objective. Who are the students?
We the students, we are.
You're the students. Great. So we're going to understand what a function is. A function is a rule. Each input has exactly how many?
One
output. What's our second objective? Dean, what's our second objective?
Students will understand that a graph of a function is a set of ordered pairs consisting of an input and a corresponding output.
That was a hard word and you nailed it. Good job. All right, so our second objective, once again, who are the students? Wendy, are you the student? All right, you are. So we're going to actually graph some functions today. How fun is that?
Yeah, how slamming is that?
It is slamming, Dee. I agree. All right, so my teaching points today, what is a function? So at the end of class today, I'm going to ask, what is a function? And I expect every one of you to be able to tell me that a function is a rule.
A function is a relationship.
A rule is a relationship. Very good. Do you know, we use the word rule, but as we go along in our unit on functions, we're going to switch and change to the word relation. That's a more challenging way to look at functions is when we use the word relation or relationship. For today's lesson, we're going to stick with the word rule. But good job, Nathaniel. We're going to talk about function tables, and we're going to talk about how we know how to graph a function using the x and the y axis. Now remember, a lot of this stuff we've already talked about. Remember when we talked about patterns, Wendy? And we had all the numbers and we had to figure out what came next? Yeah, we had a lot of work on patterns that we did. And who remembers all the work we did on ratios? Do you remember any of that?
Yeah, the shapes.
And we talked about shapes. Very good.
Patterns.
Shapes. And what else did we do with linear graphs? Do you remember that? Remember we had the manipulatives and you had to identify the parts? You had to label it. Good. And so that's when we learned about the x-axis and we learned about the y-axis. Now which way does the x-axis go?
The x-axis goes across.
Across. But what's the math term for across?
Across the input.
What type of line is that?
Horizontal.
Oh, yes.
Horizontal. And up and down on the y is vertical.
Woo! You rock. So you did remember. Good job. So all of those things we've already talked about is really going to help us when we talk about functions and understanding what exactly is a function. Are you ready?
Yeah!
Fasten your seatbelts because it's going to be a bumpy ride. All right.
Bumpy ride.
Yes. What is that?
I'm sorry, a vending machine.
A vending machine. Another word for
Soda machine.
So who can I want you to tell you what, we're going to work with an elbow partner. So Avery, your partner, you two partners, two. I want you to talk about what you see in this picture and what is the purpose of that machine. What does that machine do? And then I want you to decide whether or not you think that is a good representative of a function. Remember, a function has a rule, and the input has exactly one output. So go, talk. Let's hear it.
What does the vending machine do?
What does the vending machine do?
What do you put inside the vending machine? What do you put inside? Do you put paper or money? How much? It's $2 or $1?
We put $1.
Okay, we can put $2 if you want to. But the machine. What color is the vending machine?
Not anymore. That's $41.
Okay, time.
Juice.
I'm having a great conversation. Now let's hear what she has to say. What is the purpose of this machine? Who can explain it to me? Dean.
Oh,
What is this machine?
the machine.
Explain it to me. What does it do?
When we put the money in, is input. When we take the soda is output.
Do we agree with that? Dee said, if I hear you correctly, you put something in, like money, and you get something out, like a soda, right? So, if I put in $1 and I push the button, I expect that 1 soda would come out. Very good. Who else agreed with that? Do we agree that it's a function?
Yes, I agree.
Yeah.
Yes.
You do?
Yes.
Andrew with me? All right. Let's get a little more complicated. What is this?
A copy machine.
Where can we find a copy machine?
In the office.
Yeah, there's one in the office.
In the
We've all
office,
seen it.
got copy machines.
That's right. On our job sites, we might see it, right? Secretaries use copy machines a lot.
Secretaries.
Mr. Eddie in the school,
He makes copies.
he makes copies
to
on one of these.
everyone, the teachers.
Now I want you to take a couple more minutes and I want you to do the same thing with your partner. Tell me what the purpose of that machine is and whether or not you think it's an example of a function.
What is it?
What comes out of it? Is okay. What is that? Movie? Copy machine or soda
What is
machine?
it?
What do you put in the copy machine? Do we put soda or paper? And what comes out of it? Does it come out of paper?
Okay. Do you think that a machine is a function?
Same thing you put in that comes out? Yes or no?
Alright, let's hear your thoughts on this one. It's a little more challenging, I think. What did you think? Who can explain the purpose of this machine?
Yes, it is a function copy machine.
Oh, I hear some great discussion. Adonis, what's the purpose of this machine? What does it do for me?
The machine looks a function and is rolled the paper and this side
Okay, I put a piece of paper in.
and
Do
push the buttons.
Okay, and then what comes
slide
out?
down and printer. It's copy.
All right, so do we
Printer.
agree that it's a function?
Yeah.
It's a function.
I agree.
What did you guys decide? Yes? Wendy? Yes, thumbs up?
Yes.
All right, good job. So, let me think before I go on. The real world. Do you know, I'm going to tell you a secret. Come here. Shh. I don't want anybody else to hear. Don't tell anybody outside of this room.
Okay.
Promise?
Yes.
Promise.
There are function machines galore in the real world. And I'm going to tell you one right now. How many of you have heard of Facebook?
I heard Facebook.
How many of you have a computer in front of you? Oh my goodness, do you know? Have you ever been to a bank before?
I had bank.
There are so many companies, machines, programs that are really just functions. Don't tell anybody. So it's important that we understand it because they're all out there. When we leave school today, you're going to say, oh, maybe that's a function. Whoa, that's a function. You wait and see, it's going to happen. All right, so let's learn some new words. Who would like to read our words, our vocabulary for us? All right, Nathaniel.
Function.
Keep going, all the way down.
Function. Relation.
Relation.
Rule. Input. Output. Function. Machine. Function. Table. Order. Pair. And group. Graph.
That's okay. We're going to be talking about these all through the lesson. Some of them you already know and you've already discussed them. What an input is, what an output is. We talked about relations. Remember our pictures? This was one of our previous lessons. Who's this?
Snoop Dogg.
Snoop Dogg.
But EJ's name.
Who is it?
Taylor Swift.
Taylor Swift.
Bruno Mars.
Two Bruno Mars.
He's single.
And that's all. All right, so how are these three related?
They are three singers.
They are all three singers. Do they all sing the same type of music?
No.
No,
They
he's
all
a
sing-
rapper.
Snoop Dogg
She's
rap.
kind of country pop. He's probably really just pop, right? So,
He's not a rapper anymore.
Oh, sorry.
He's not right.
Didn't mean to
I
offend.
mean, he still is, but he's
Okay, well, we
regular.
could have a whole conversation on whether or not he's still a rapper, right? Or legit or whatever.
Still regular.
All right, but the point being is that they are related. All right, let's see, what's a function machine? We've kind of touched on this. Is it a real machine?
No, it's fake. It just pretend.
Oh, it's just pretend. All right, to help us understand how functions work. Good. When we talked about linear graphs, we talked about ordered pairs and how to write an ordered pair and how to graph ordered pairs. So we're going to do a lot more with that today. And of course, we've worked with graphs where we're going to talk about the x and the y-axis. So, what is a function? Stephen, what's a function? Do you need to get a little closer, buddy? I forgot you had trouble seeing. So, who can help him? Amanda, what is a function?
Function is a relation between two sets of numbers, input and output.
So somehow our input, what goes in, and our output, what comes out, are related. All right. Oh, wait a minute. What does this mean? It has special
rules.
Andrew, what's our special rule for a function?
Every one.
It must work for every possible input value.
All right, remember we have to check all of our numbers, all of our input, because if it only works for 1 and 2, then it's not our rule. We have to keep looking. And then the other special rule is we can only have one relationship for each input. In other words, for every input, we're only going to have how many outputs?
1.
1. So a relation, just to sum up, is just a connection between 2 or more things. So how are our input and our output connected? What's the pattern? A rule shows the relationship between inputs and outputs. Oh, I love this. If the numbers are getting bigger, increasing, what do we do?
Subtract.
Let's think about it.
No.
You add or multiply.
Oh, good, Avery. You add or you multiply. Now, if the numbers are getting smaller, they're decreasing. Adonis, what do we do?
Increase.
No, if they're decreasing, if they're getting smaller, what do we do? It's okay, look. What do you do?
It's subtract or divide.
Very good. You subtract or divide.
Or divide.
All right, so there are 3 parts of a function, and this will help you when we get into our small groups. There's the input, which we already said, Adonis, is what? The x.
The x.
The rule, or how the numbers are related. And then we have the output, which is what, Wendy? Very good. All right, so here's an enlarged function table, right? Oh, wait a minute, function table. Yeah. What do we use a function table for? Why do I need a function table? Can't I just do it in my head?
No.
I could, maybe, but what does this help me do? I'll give you a minute to think. Oh, I'm going to come back to it. I want you to answer why we use function tables when we're working with functions. What does that help us do, Avery?
To solve the rule.
Oh, to find the rule, to look for the pattern. Sure, it can. And it's a great way to organize the information. We're going to be working with a lot of numbers, right? So it's just a tool to help us organize those numbers. All right, so we have our input and we have our output. So all of these will be my input, all of these will be my output. And then there's going to be a rule or a relationship between these. If the number is getting bigger, I think, maybe my rule is to add or multiply. If my numbers are getting smaller or decreasing, I might think, maybe I'm subtracting or dividing. All right. In a minute, you're going to get to work with them. All right, so here is an example of the input. All the values that go into the function are the input. So what do you think output is? If the input is everything that goes into a function, what do you think output is?
It goes out of a function.
Ooh, let's see, Avery. all the values that come out of a function. Good job. That's our output. So let's do an example together. Well, we talked about a function machine. I think Nathaniel summed it up very well. It's just a pretend, right, to help us understand the concept. You know what? You guys don't even, I'm going to be honest, y'all are way beyond a function machine. But let's just show you what it looks like. What number is my input?
34.
What's my rule or the relation?
Plus 6.
So what is my output?
40.
Do you see how that works? Stephen, did you get it? I put in 34. Something happens. I have a rule. Oh, it's plus 6. 34 plus 6 equals 40. Boom, there's my output. Okay? So 3 steps to success. I really, really, really need you to pay attention to this. You look? Okay. Number 1, analyze how the input and the outputs are related. You're going to have to use your detective skills to figure out, Amanda, how the numbers are related. Okay? How the input and the output are related. The second step, you're going to come up with a function or a rule. Am I going to add? Am I going to subtract? And then the third step, which is very important, you have to try it on all sets of numbers. Because remember, it's not a function if the input has more than one output. All right. So let's do one together. Here's my input. 1, 2, 3, 4, 5. Here's my output. 2, 3, 4, 5, 6. What's the first step? Nathaniel?
Look for a relation between the input and output.
Are my numbers, is it getting bigger or are they getting smaller?
It's getting bigger.
So what do I do if my numbers are increasing? Andrew, do you remember? If my numbers are increasing, I'm going to either multiply or add. All right. Step 2. Stephen, what's the second step? Come up with
a rule.
So, Stephen, did you come up with a rule yet? Let's see. I'm going from 1 to 2, 2 to 3. What do you think our rule could be? I know I'm going to add or multiply. What do you think? Not sure? Not sure. Adonis, what do you think? Have you figured a rule yet? Can you find a rule?
The rule is it has to be plus 1 in it.
Plus 1. All right, let's look at our final step. Check your rule on all numbers. So we have to check it. What's 1 plus 1?
2.
Check. What's 2 plus 1?
3.
Check. What's 3 plus 1?
4.
So far, so good. 4 plus 1?
5.
Ooh, I think we might have it. 5 plus 1?
6.
It worked on every single one, so yes, the rule is plus 1. Good job. All right. So why do we care so much about functions? We already talked about how they're everywhere around us in the real world, right? And 2, it's really cool to plot and to graph a function. It gives us a lot of information. And remember how we write an ordered pair? The input always comes first, which is the X, and the output always comes second, which is the Y. That's why it's called an ordered pair, because the order they come in really does make a difference. So look at this example. Here's my ordered pair, 4, 16. All that means is my input 4 and I outputted 16. All right, so the pair of numbers giving the location of a point is an ordered pair. And then here's an example of our graph. Now, what I want you to notice about this graph is, look at this. What do you notice here and here?
That's negative numbers.
What? I didn't even know there was such a thing as negative numbers. You're kidding me, right?
It's up there, is positive numbers.
Very good. That's the key. I want you to be aware. On the x-axis, everything here's 0, right?
Yeah.
Right, smack dab in the middle. Well, not gonna do that.
I think small boys acting up.
That's okay. Everything to the right of 0 is positive. Everything to the left is negative. Everything on the y-axis above your 0 is positive. Everything below is negative. All right? All right, so we're going to get into some groups. Let's see. Group number 1. Adonis, Wendy, and Stephen. I'm going to let you go to the, just a moment before we move, let me give you a few instructions, and then we'll get where we're supposed to go, okay? But you're going to go onto the floor and by the sink, okay? So there's that. Our second group, Andrew and Avery. Andrew, if you don't mind, just, not yet, buddy. You'll just come sit where Adonis is, okay? And Miss Cassie's going to be your facilitator.
What's facilitator? What's that?
And then group 3 will be at the round table with me. So that will be Dee and Nathaniel and Amanda. Everything we need will be provided. You don't need to bring anything. Here's what you're going to do in your small group.
Yeah.
Wendy, I'll wait. Thank you. I need you to pay attention, okay? In your small groups, everybody's going to have a big function table. And you're going to have some numbers to complete your function table. All right? Also in your packet, you're going to have a word problem or a text. And you're going to read that text, those word problems together as a group, and then you're going to solve, right? And you're going to complete your function table. You're going to write an algebraic equation, and then you're going to graph your function if we have time, okay? So those are the 3 things I want you to do. But the most important thing I want you to do is to discuss. All right? I want you to discuss your thinking with one another. All right, so you may go to your groups. That's your board. Sure. All right, have a seat, Dee. Here's our numbers in the back. So one of you can be our numbers person.
I can be the number person.
All right, who wants to go ahead and start by reading our word problem? All right, go ahead and read it. Go ahead and read.
Miss Cassie and Miss Jasmine are preparing food for a class breakfast. The first task is to crack eggs into a bowl for scrambled eggs. There are 8 cartons of eggs, and each carton contains 6 eggs. How many eggs are in 2 cartons?
Use the function rule to find
And who would like to read the second part? Nathaniel?
What is the output value? If the input value is 4, what is the output value if the input value is 6? What is the output value? If the
36 miles per
if the input value is 8,
the dragonfly travel?
And Amanda, read that for us.
Oh, wow. Discuss. If your group Y and figure out the correct output values in the function table.
All right, so how many cartons of eggs are there? How many cartons of eggs? Find out and circle it.
There
are 2 eggs.
no,
How many cartons are there?
it's 8.
Circle it so you can have the information there.
8 right here.
And how many eggs are in each carton?
6
Where do you see that?
right here.
All right, circle it. So if you have 6 eggs in 1 carton, how many would be in 2 cartons, Amanda?
3.
Okay, why do you think that?
You will use the function.
What two
to find
numbers
out-
would you multiply?
Find the output value using this function for table.
If I have, draw a picture, Amanda, if you don't
The
know.
fastest insect
How
in the
many
world is the
cartons?
dragonfly with the top speed of 36
How many eggs are in
miles per
one
hour.
carton?
How far will the dragonfly travel after 4
Oh,
hours?
very good. So you would have 12 eggs and 2 cartons. All right, so let's see. Get our numbers out. Let's fill out our function table. Nathaniel, do you mind doing that for
Sure,
us?
I could. Sure.
All right. So it says the input is 4, 6, and 8. So we can go ahead and fill in our input.
4.
36 times 4.
1.
You mean this one?
He's going to do it on the big board, but if you want to do it there, that's great.
1.
That's what that's there for.
You say 4?
What does it say on your page?
36.
It says 4, 8. No, 8, 6.
I'm going to let you figure it out. What does it say there?
It says what if output value if the input value is 4.
Help him out, guys or girls. So what would come next after the 1?
4.
4.
Okay. Then what?
4.
What? Okay.
6
Can you write that on your
and 8.
So now we're on 2. What is the rule?
Now, how in the world are we going to find the output? What is our rule?
Have to multiply.
Why do we have to multiply?
Times 6.
Oh, because why 6? Where'd you get the 6 from?
From here.
Because there are what?
Because there are 6 eggs.
In each
Each
Now, Andrew,
egg.
carton. Okay, I'm going to leave you for a minute. I'm going to go check on everybody else. I want you to go ahead and fill out your output then. And you think you found the rule, we're going to check it and make sure that that's true.
Me, 3 times 6.
Okay, you try it. If that's what you think it is, go for it. How are we doing over here? You guys have big numbers you're working with.
say it again, Avery? 144. Right, so let's put 4.
Good job.
15 again.
Plus
5 is 20.
Mm-hmm.
Is it in? The 20 again.
Let's see if Wendy or Steven can come up with the next one. What comes next, Wendy?
So the rule is?
What did you say the rule was?
Times 36.
So what would come next?
So
Very good.
20 plus 5,
Write an equation using x to present hours and y to present
20 plus 5,
So now, we would put X.
20 plus 5, 20 plus 5. Steven, you want to help Wendy? 25. Good job. So
What's the next? Steven?
So remember when we saw the PowerPoint, the first step was to see how they are related, and you told me they were getting bigger or smaller?
It was getting bigger.
Oh, and that's why you decided multiply.
Yeah.
All right, so now you're filling in the rule, right?
There you
for
go.
each input.
I got it.
All right, so let's check them. The third step to success is we have to check and make sure it works for every input has exactly one output. So do we agree that it's a function?
Yes.
Yes.
Well, let's finish it and see. And then we're gonna graph it.
That's okay. Don't worry about it.
So how would I write an equation to show that? Amanda, how would we write an equation to show that?
Thank you, man.
Oh, you're like the Vanna White. Good job, Amanda. Do you ever watch Wheel of Fortune?
Yeah.
She's like Vanna.
Yeah.
All right, so let's check and see. Does it work for each?
Yeah.
Does each input have exactly one output?
Yes.
All right, so I want to see how you would write an equation with your rule. Y equals what?
Y equals times 6
What times 6?
equals
Remember the input is what?
X.
Very good. So There you go. Remember how I told you could write times 6? In parentheses that meant to multiply? So like this. See how Amanda did it? That means to multiply.
72, so we're gonna go up.
Well, let me show you, Nathaniel. Almost, buddy. Very close. So you have X. Now do your open parentheses. Parentheses. Now put your 6 and close your parentheses. There you go. Very good. Now let's see if you can graph that function.
Not right.
Why not? Let's try it.
I think it's hard.
Y equals 6. So 6 equals 1 times 6. Is that true?
Yes.
Does 6 equal 6?
Yes.
Yes, that's a true statement. It does work. Here you go, Amanda. Let's see if we can graph this function right up here. So what's our first? Remember our ordered pair would be 1, 6. So where's 1 on the x-axis?
1, 6.
So over and then up. So over 1 and up 6. So it's going to be right above the 5. There you go. Now what's your next one, Nathaniel? 4?
24.
There you go. There you go.
Yes.
So what's our first ordered pair, Amanda? 1, 6. So how would you find 1, 6? Nope. We go over 1 and then up 6. Remember, this is always the X and the output is always the Y. So we go over 1 and up 6. Which there's not a 6, so we're going to go right above the 5. There you go. Good job. Now what's our next ordered pair? 4, 24. Let's see. Are we going to have a line there, Nathaniel? It's a function. And guess what? It's linear. Remember what linear means?
Function.
Linear.
Linear line.
Very good.
Listen.
Nathaniel, I'm going to let you be a helper if the girls have a question.
Okay.
6,
How are we doing over here?
36.
All right, guys, we're going to wrap it up in a couple of more minutes, okay?
So go ahead, 10. Wait, hold on. So we check on 10, right? Remember? In where? In the...
10 in the
Which one? In the X or the Y?
in X.
In the X. All
10 in the
right.
X.
And then what was our out?
And the out is 15.
15. Good
So
job.
remember, the X is always over and then up.
So it was 10.
So is this a function?
Guys.
Did you check it? Wendy, is this a function? Yes. Oh, okay. I can't wait to hear all about it. Yes.
Good job.
Remember, I need a spokesperson
Yes.
because we're going to share our findings, okay? So y'all can decide who wants to be the spokesperson.
What's the next one, Steven?
15.
Where the 15 goes? In the
Dee, did you graph yours? That's okay. You have a
15
couple
goes
of
in the
minutes.
X or the Y in the X.
So what's our first ordered pair? You okay?
So afraid.
Why are you afraid? Do we need to go move our name on the mood meter? You okay?
Yes, I'm okay.
If you need to touch, what can you do? What can you do? You can squeeze my hand. I like when you squeeze my hand, but no touching others, okay? That's Amanda's space.
Sorry, Amanda.
Thank you. All right, so what's our first ordered pair?
1, 6.
Very good. So we go over on the x-axis 1.
1.
And then we go on the y-axis, we go 6. Where's 6 at? Well, there's not a 6, so we're going to have to kind of put it right there.
1, 6.
Amanda, can you put your name, and Nathaniel, put your name
What is
and today's date for me? So over 1 and up 6, so right about there.
This is not 6. This is 5.
Well, but we didn't put it right on the line. See, we put it a little above. Is this challenging? It's okay. What's the next order pair? 4, 24. So go over 4 and up 24.
4. Let me help.
Nathaniel, can you help her with that one? 424. I think.
424. It's right here. 4. See 4. 24. Right here. About to 25.
Excuse me. 4.
Yes. And then go up.
25.
4.
Well, that's 3. So let's go to 4. Now go up to almost the 25.
That's 25.
All right, guys. I need you to wrap it up and get back to your
This
seat.
one.
Yeah, 4.
I need you to
4
do one
about
thing for me
25.
though before you take it down.
This one.
We're gonna share it, okay? So can you put your numbers back
Four
real
about
quick?
25.
Thank you.
Like this one
They're
here.
gonna
4
need
about
their
25.
Yeah.
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 dry erase marker and their calculator and their pencil, so they can take that back to their desk.
Can't see.
They will each need a dry
Pencil.
erase marker and a pencil and a calculator, so they can take that back to their desk. Who's gonna be my spokesperson to tell about your function? All right.
636. So it's
All right, let's go back to your
35?
seats.
Yeah.
Careful.
what? I almost finished.
Yay, Dean. Sorry, buddy.
Hey.
It's
Say
okay.
sorry.
He said
It's all right,
sorry.
it's all right.
Thank you. You finished. It's okay.
Help me, Miss Wynn.
Sure.
646.
Amanda, take this with you,
36. I
sweetie.
found 36.
Okay, well, where is 36 close to?
Yeah.
It's close to 35, right? So go right above 35. Right there. I love how you're persevering and not giving up. I love that about you, Dee.
Yeah.
Even when things are hard.
848.
So over 8 and up 48. So 48 is almost to 50. Keep going, keep going, keep going. Right there. Good job. Boy, I'm proud of you. All right, I'll meet you back at your seats. All right, let's see. Come on up. Group 1, come on up.
Yeah.
Okay.
Now, when people are presenting, we use our good manners. We're good listeners, right? That's a standard that we're good listeners and we're good speakers. All right, who's our spokesperson? All right, Adonis, take it away.
Okay. After 10 minutes of playing, after 10 minutes of playing, the PS Arena and Lions basketball team scored 15 points. And the team continues to score 5 points every 5 minutes. How many points will they have after 30 minutes?
What was your rule, Stephen? What did y'all come up with? Plus 5. How did you know it to add? How did you know to add and not subtract? What did you notice about your numbers? Were they getting smaller or larger? Ah, good job. So, did you graph? Were you able to graph your function?
Yeah.
Is this a function?
Yes.
Show me. Prove it.
This is 10 and the plus 5 is 15.
Okay.
And the 15 plus 5 is 20.
Okay.
And the 20 and plus 5 is 25.
So far, so good.
And 25 plus 5 is 30.
So it worked on all your numbers.
The word
Way to go. Good work, Wendy.
Numbers.
Thank you. Very good job, Adonis. Thank you, Stephen. Next, group number 2, Andrew and Avery. Your turn to shine. Drum roll, please.
Avery and Andrew. Best friends for life.
You want to read it, or are you going to read it?
Let's see.
The problem, your text. Who wants to read that? So the rest of us can kind of be on the same page. Here, this.
The fastest insect in the world is the dragonfly with a top speed of 36 miles per hour. How far will the dragonfly travel after 4 hours? What's the rule? Write an equation using x to represent ours and y to represent this.
So you're representing X and Y. Okay, so tell me about it.
We did times 36.
How did you know to do multiplication?
You can't do this one.
Oh, it would take forever, right? You're right.
It will take forever.
Were your numbers getting bigger?
Yes.
So that's why you chose.
Increasing.
Okay. What was your rule, Avery? What'd you multiply by?
36.
And is this a function?
Yeah.
How do you know it's a function? Did your rule work for every set of ordered pairs? Yay! Did you have time to graph it?
1 is 36. 36 times 2 is 72.
Okay.
36 times 3 is 108. And 36
Okay.
times 4 is 144.
Ooh, I'd have to use a calculator, but I trust that you're right. Good job. Did you have time to graph it?
Yeah.
Okay, good. Perfect, thank you. All right, last group, come on up. Group number 3. Who wants to read yours? Okay. Thank you, Amanda.
Okay, Miss Cassie and Miss Jackson are preparing food for a class breakfast.
Yes.
Their first task is to crack eggs into a bowl for scrambled eggs. There are 8 cartons of eggs and each carton contains 6 eggs. How many eggs are in 2 cartons?
How many eggs are in 2 cartons, Amanda? We didn't do that on our function table, but we answered that at the table. Do you remember?
What?
Very good. Continue, Dee.
What is the output value of the input value is 4? What is the output value of the input value is 6? What is the output value if the input value is 8?
All right, so Nathaniel, tell me, what was your rule here?
It was rule times 6.
So is that a function?
Yes, it is.
How do we know that's a function?
Look, see, 1 times 6 is 6.
Okay,
And 6 times 4 is 24.
okay.
And 24 times 6.
Wait,
6 times 6 is 34.
There you go.
And 8 times 6 is 48.
Very good. Did you have time to graph it?
Yeah.
All right, so what did we notice? Everybody had time to graph. What did we notice about our functions once we graphed them? What did they form? I don't know. I didn't graph it. Look at your graph. What did it form?
A line.
Oh, hello. Thank you, Avery.
We formed a line.
They're linear, right?
Linear.
Very good. So everybody should have had a line on the graph. Are we good?
Yeah.
Thank you. Very nice job, everyone. You may have a seat. Good job. All right, so now it's your turn to shine. I want to see. Now, I already know. I don't need to see what you know. I already know what you know. But I want you to be able to show what you know. Now, this is going to be very challenging. I'm just going to be honest with you. So I need everybody's attention. Everybody's attention. Thank you, thank you, thank you. All right. Persevere. I need you to persevere on this next activity. I'm challenging you. I think what we did was great, but I want to see if you can go a little further. I'm going to increase the rigor.
Increase?
Okay? I'm going to increase it just a little bit. I think you can do it.
What's increase?
Increase means I'm going to add to it, to the complexity, a little bit, because I'm throwing you some negative numbers. All right? Don't worry, you have a calculator. We've practiced. I'll wait. I have some sleepy heads. I'll wait. The way I know you're paying attention is I get to see your eyes looking at me. There we go. There we go. We're good. Dee, you didn't want to come up here? All right. So I want you to persevere. It's going to be challenging, and that's okay. Remember, this is a safe room. It's okay to make mistakes. It's okay to ask for help. And it's okay to use a coping skill if we get frustrated. As a matter of fact, Miss Wynn is so not in red anymore. La la, I'm so happy now. Remember earlier, before we started, I was a little anxious and a little, well, a little disappointed and upset. I'm over it. All right. So what you're going to do is you have a calculator, a pencil. You're going to complete the function tables, and then you're going to graph the functions. Now, for time's sake, I've highlighted the ones I'd like for you to do. You do not have to do the whole page because we're going to run out of time. As a matter of fact, let's just do one. How about that?
Yeah, one.
We'll finish this tomorrow because tomorrow's lesson is going to be a continuation of today's lesson, right?
Yes.
And I still need you to do your self-assessments, and I still need to assign homework.